Hey all, welcome to lesson 9. This will be one of two parts for this, but I wanted to break the video apart into percent error and then another part on dimensional analysis, since both are, I think, pretty interesting and can be tricky for people. So let's begin with percent error in this video. Percent error is a measurement of the percent that it's off. So you take a measurement, what it should have been versus what you measured. And that's what it is. So the measured value is the value you get. So you take out a ruler. What you measure is the actual value you get. The accepted value is the value you should get. There actually is a real dimension to that. And so that's what you should get. Or it's accepted by research. So, but in science, we never get this accepted value all the time. It's actually a sign of not doing things correctly. If you always get the accepted value, your measured value should have a certain amount of percent error. What is percent error? Well, the formula is pretty easy. It's found in table T in your reference table, the very back page. It's given as percent error. It can be used in a lot of different things. So what's nice about learning this is you'll learn it in almost all of your sciences and math class. So it's your measured value, and then you just subtract what you should have gotten from. So accepted value. And then you divide by the accepted value. That's the known quantity. Let's take a look at this formula and how it works a little bit before we go forward. You'll notice that you're subtracting two values. So if you have, there we go. If your measured value is higher than your accepted value, and then what happens is you will get a positive number here, a positive percentage. It means you overestimated. So positive numbers means you overestimated. And if you subtract a small number from a larger number, you get a negative value, and that negative means you underestimated from the true value. So that's what we want to say there. Oh, it's right there. So go ahead and fill these in with what I just taught you. If negative, your measured value is blank. If positive, your measured value is what? And this should be less than. And if positive, it means it's greater than the accepted value. There's not a whole lot to this other than practicing the mathematics. So let's go ahead and do that. Where's my, make sure you can see my camera. That's my calculator anyway. I don't see it, but maybe you guys see it. Let's take a look at the sample problem. In a lab experiment, you were told by your teacher the actual value of sugar in a can of Coke is 39 grams. Experimentally determined to be 40 grams. Based on your own data and calculation, what is the percent error? So it's pretty straightforward. What you're going to do is say percent error. Now I'm going to abbreviate a little bit here and make sure you can follow along. I'm going to write m minus a over a. And then to actually get it in percent form, we're going to multiply by 100%. You know what? That's something I didn't do up here. And the formula, you need to have the 100%. You multiply this by 100 so that it converts it to a percent. All right, so now we have this. We just plug the values we know to be in. We say our measured value is 39. Our known value is 40. We divide it by the 40, and then we multiply by 100. All right, I'm not sure if you can see that or not. I'm hoping you can. I'll zoom in a little bit, or maybe I'll just switch. Not sure if I can switch or not. Yeah, perfect. Just switch it to the larger screen. So we had 39 minus the 40 divided by the 40 times 100. And that gives us negative 2.5%. That's all there is to it. sorry. Try to get back to my share screen. Here we go. So we have this as 2.5%, but negative because it's an under value. All right, hopefully that answers any questions you have. That's it for the notes. Your practice packet, it does have homework in it, and you want to work on that in class, as well as on the dimensional analysis. Let me just get to that page so you understand. I wouldn't say it's tricky, but it is not in the traditional sense. It's on page 20. Let me just find this perfectly. It says percent error problems, but it's also next to the density problem. So you just have to recognize you're going to be working on this, but it's going to be just underneath that. So there are 140 calories, let's say, in one. I just did one like this. Let's try another harder one. How about this one, number 4? Working in a laboratory, student finds the density of aluminum foil, aluminum to be 2.85. The accepted value is 2.699. What is the measured or the percent error? So you say percent error equals measured minus accepted over accepted times 100. And in this case, the density of aluminum foil to be 2.85 in their experiment. That's what they measured. But we know from the handbook that say that the density is supposed to be 2.699. So we divide that by the actual accepted value and then multiply by 100. Now, keep in mind, I'm going to ask you to always be aware of significant digits. So in this case, I'll also show you some tricks to putting this in the calculator all at once, though. That can lead to errors if you're not careful. I'm just putting parentheses, but everything on top divided by 2.69. And I'm usually pretty good at making a mistake, just to show you, of course. And I get this, but that's not the full story. That doesn't give us, oh, let me go back to sharing. So as you saw, our calculator was 0.055946 and blah, blah, blah. But we have 3 sig figs here, 4 sig figs here. When we subtract this, we can be no more accurate than 3 sig figs because it's the hundredths. And then when we divide that answer, we can get no more exact than 3 significant digits. So our final answer will be, actually we'll only get these to 2 sig figs. So it will be, because this answer here will be only up to the 100th place. And what we'll have is our answer 0.0. Oh no, move it over 2 places, 5.6%. We have to multiply that by 100. So that's what we're looking on that practice packet problem. Hopefully you understand how to set up the formula, do the math, round it to sig figs or significant digits, and you're all set. Thanks. Have a great day.